Today, we are diving deep into something pretty amazing. We're going to crack open this hidden connection between, of all things, the shimmering, perfect structure of crystals and the invisible math that guards our deepest digital secrets. Let's get into it.
I mean, it sounds like something straight out of science fiction, right? Can the exact same rules that build a diamond also be used to tear down the very foundation of internet security? Well, that is the fascinating puzzle we are going to piece together today.
So we're starting with this pair that seems, well, totally unrelated. You've got solid, tangible crystals on one side, and then these abstract, invisible secret codes on the other. What on earth could they possibly have in common?
To really get this, we're going to take a quick journey. First, we'll pop into the world of atomic architecture, how things are built. Then, we'll jump over to the world of digital security. And only then can we build this secret bridge that links them in a way that is, honestly, just profound.
Okay, so let's start with something we can all picture. The beautiful, orderly world of crystals. It really is all about finding the hidden patterns that nature uses to build stuff.
Now, the science behind this is called crystallography. And it's really just a fancy word for understanding the blueprint of how atoms arrange themselves. If you think of a huge skyscraper, crystallography is like studying the architect's original plans, but for things on a ridiculously tiny, atomic scale.
And the real secret to this atomic architecture? It's just repetition. See, everything in a crystal comes from one tiny basic building block. It's called a unit cell, and it just repeats over and over and over again. It's exactly like how a single, beautifully designed tile can be used to create a massive, intricate floor.
So here's the key takeaway. A crystal is basically a grid of atoms. They call it a lattice. That grid is built from that one repeating unit cell. And because of this, the entire structure is incredibly predictable. It's not random at all. It's pure, structured mathematics that's been made physical.
All right, let's put a pin in that idea of predictable mathematical structures. We're now jumping worlds into the abstract realm of numbers, specifically the numbers that protect our digital lives every single day.
You see, the core idea protecting your bank account, your emails, your entire online life, it's all based on this weird imbalance in math. It is super easy to multiply two numbers together, even really, really big ones. But it is brutally difficult to take the answer and work backwards to find the original two numbers you started with.
And this right here shows the problem perfectly. If you ask a computer, hey, what's 37 times 73? It'll tell you in a flash. But if you ask it what two prime numbers multiply together to make 2701, well, that's a whole different story. You pretty much have to guess and check. Now, imagine that number isn't 2701, but a number with hundreds of digits. That is the lock. And this is no small thing. That difficulty in working backwards, in what's called factoring a large number, is the fundamental principle keeping almost all of our modern encryption safe. It's the mathematical wall that protects all of our information.
Okay, so remember that predictable mathematical structure of crystals? And remember that super hard problem of finding a number's factors? This is it. This is the moment where these two completely separate worlds are about to smash into each other in the most brilliant way.
So the breakthrough idea is this. What if, instead of trying to break that lock with brute force, you could find its secret frequency? Like an opera singer hitting that one perfect note that can shatter a wine glass? What if you could just ping a large number and listen for the echo of its factors? That's the whole idea behind resonance.
So here's kind of how it works, as an analogy. First, you take that big, hard-to-factor number, and you use its properties to mathematically build a virtual crystal lattice. Then you start to ping this lattice with all sorts of different mathematical frequencies. And this is where the magic happens. When you hit just the right one, it resonates. It creates this measurable spike. And that spike, that echo, points you directly to one of the original factors.
And that is the connection. The reason this whole thing works is because the math of crystallography, those predictable repeating patterns, creates the perfect concert hall to listen for a number's hidden rhythm. You're using the perfect order of one world to find the hidden order in a completely different one.
Okay, so this is a really beautiful piece of mathematics, no doubt. But what does it actually mean for us in the real world? Why should we care about this bizarre connection between crystals and codes?
Well, the implications are actually huge. For one, this could open up a totally new path for building powerful computers, which could, in turn, be a new challenge for our current encryption. But, it's more than that.
It reveals these deep, hidden connections inside mathematics itself, and it proves that patterns we find in nature might hold the keys to solving our most abstract problems.
Ultimately, this goes way beyond just being a clever trick. It's a real insight that the mathematical rules that govern how a snowflake or a diamond grows are somehow woven into the very fabric of number theory itself. It suggests this underlying unity to the universe that we are only just beginning to grasp.
And that just leaves us with this final, really fascinating thought. If the blueprint for a crystal can help us unlock our digital secrets, what other answers to our biggest questions are already written out there, hiding in the silent, unseen patterns of the world all around us?